Quit objectifying women. That's not nice.
So Lab 4 is a little bit challenging, I believe. Even though I already provided the starting code, the template in the video, you can watch the video and type it to your MATLAB. If I provide the code, the template, you are probably not typing anything at all. So the video is the most I can provide. And so today, 3 to 4 p.m., there will be 3 TAs having office hours. So there will be at least one, right? Since 3 of them are having office hours at the same time. Usually they will probably all be there. And Wednesday there's another office hour session, so you can find help from them. And also you can email me for help as well. Okay? So you haven't finished the Lab 4 yet, and we start introducing Lab 4 today. I'll have to because there's a lab on Thursday, right? Yeah, sometimes I'll see how you guys doing, and we may have one of the labs make it a 2-week lab. I don't know, depending on your progress. But definitely, after Lab 5, you'll have a break, which is this week's lab. So no lab next week, right? Because next week there's a midterm exam. So what are going to be on the exam? I'm gonna doing a review for that.
Why can't you give us the source code again? Because going through the video, you have to like really slow it down to actually see all of it.
I know, typing it or not typing it makes a difference. So type it, what you go through your brain a little bit at least.
But it's like you can't really even see all of it.
Yeah.
Because of how the video is.
They didn't provide it in the past at all. So I think I already did a lot. I don't know. I have to ask Dr. Carlson and see if he gives me the permission to do it. Because if the template is provided, it probably will be spread to a lot of people immediately. I have to ask the TA and Dr. Carlson first, because they worked on this lab, developed all the lab for 5 years to get everything done. If all the templates are out, yeah.
Would you by chance be willing to even provide them just like as a scroll of of pictures so that we don't have to pause on pause? If you want us to type it out so they're all at once.
Okay. All right, that works too. Let's start looking at this one. Okay, so this is one of the lecture C code. It's a new topic, unfortunately. Let's see. PWM. So if you have a square wave, it's called a 50% duty cycle, because width here and width here are the same. It's 50%. But sometimes we want to modulate it to change the width of the pulses to this. If you use the timer to toggle the pin, can you still make it? The timer overflows during the same time, or with the same durations, right?
Yeah.
So if you toggle it, timer overflows. You toggle it, overflows. It's going to be 50% duty cycle. There's no way to make a modulated pulse. So I have to introduce PWM.
Modulated. What do you mean modulated? Pulse?
Modulated is changing.
Okay.
Yeah, it's being changed. Pulse with modulation. So it's changing the width here. You can make it down to 0, then it's just directly a ground, right? Or you can make, if it's an 8-bit PWM, so you're writing a, it's as the output. If you give an 8-bit PWM, it's basically giving you the full power will be a DC voltage. So 255 is giving you 0.3 volts, which is logic 1. And 0, you're writing into the PWM, is giving you ground. Okay? Have you done PWM before? At all? A little bit? Some of you haven't? Okay, that's all right. So we have used the PWM for multiple applications. For example, driving an LED, right? So it's because microcontroller. So why do we need a PWM? Just think about it.
Certain motors run off of PWM.
Yeah.
So they'll rotate a certain, like a stepper motor will rotate a certain amount every time there's a positive pulse.
Why not just providing a different voltage though?
That way you can control the speed of the motor, so it can go faster or slower.
Yeah, if you give a lower voltage, you can also lower the speed as well. Like a DC motor, right? Usually there's a DC motor driver. I don't want to draw that anymore. So you can control the motor speed by just changing the voltage input, right? So why do we have to use this instead of just the analog voltage?
Because it's a digital system.
Yeah, that's
So
right.
you can maintain, you keep the same voltage, that way you keep the same torque with the motor, but you just change the speed.
I don't know if you can control the torque.
Well, you're not controlling the torque, you're keeping the torque constant by keeping the voltage the same, but you're using the PWM to change the speed of it.
Yeah.
Since we have a digital voltage output, we can only have low or high, so we can't provide.
That's right. Same answer there,
Yeah.
right? It's a digital chip. So output here is only ground or VCC, right? So it can only turn on off. There's no way to control it if you just use a digital voltage output. So is there another way to control it, to output a analog output from a digital chip? Have you heard about it before?
Potentiometer?
But it's not inside the chip, right?
Oh, yeah.
But potentiometer is you. You got involved.
Yeah.
You are expensive.
Yeah, I gotcha.
DAC, heard about that before?
Digital to analog.
Just a logic converter, right? So
Yeah.
DACs. There are so many different architecture for DACs. Could be resistor strings. You can get it complicated as well. But there's another device you can put in the microcontroller. I don't know if the PIC controller we use have a DAC inside. We can search for that. Very likely there will be a DAC inside because there's an ADC. Usually they will put a DAC. It's very cheap to do so. So very likely there will be a DAC inside as well. So DAC will have an analog output instead of analog input. So analog output, you put a digital input. It could be a parallel digital input from the GPLs. So they are being latched into the D flip-flops at the same time, and they will be processed and eventually give you analog output. Okay, so you can use DACs to control motors or LED as well, giving a different voltage. However, if you don't want to use DACs, you can also use PWM. The reason for that is because the on time here is controlled, right? So you can the overall power. I couldn't remember the equation to calculate the average power for the output, but you know, if you have a 50% duty cycle, for example, the overall effective power output is over here, right? If it's 5 volts, it's probably 2.5 volts effectively. Okay, if you reduce the time, the duration of the on time, the effective output is probably like 1.8 volts or something. The thing is, it's oscillating super quickly, and you won't be able to see that the LED is blinking, right? It's just blinking so fast, and depending on the on time, you are having a dimmer or brighter LED output. That's how we use PWM to control the brightness. Same for the motors. You are thinking, hey, you're oscillating on and off with a motor, so you are going to see a motor being turned on and off very quickly. Is that correct? How could you turn on and off a motor with like 20 kHz? 20K times a second. Is that possible? Probably. You couldn't even feel it or couldn't even see it, right? It's just giving you an effective output power or voltage. There's a way to calculate it, but I couldn't remember it. But just to let you know, if you have a wider on and shorter off, the power will be higher. If you have a shorter on and wider off, the output voltage converted to the equivalent DC analog voltage will be lower, right? So that's how you control the LED brightness and also the speed of the motor by using PWMs. So it's a very useful technique. And So if you look at Dr. Carlson's lecture, I already put everything and converted to my version of it. So the lecture 11 shows you a one way to generate the PWM waveforms. Okay, so now let's get getting into it. Don't get scared. I mean, these ones I don't even know. I couldn't remember. So here's the main code, the main part of it. All right, let's do it one by one. No worries. So first one, CCP1. So what is CCP1? CCP1. That's a compare capture PWM. Is it PWM? I couldn't remember. So this is compare and capture. So there are 3 different modes to generate PWM with the PIC microcontroller we have. One is called compare. We're going to talk about the details later. Don't worry about that. Don't get scared. So one is called compare. So this lecture, this web page is introducing the details of how to do the compare. And second one is called capture. So capture is taking a output signal from the pin, whatever the PIC is detecting from the output, the GPLs, and then it's gonna toggle the PWM pulses. So I don't believe there's any examples on his website or in his class having students to use capture mode. So it's either the compare mode or the normal PWM mode. So they are using different register sets. For the lecture, this web page itself, pretty short. You see the scroll bar here. Not too bad, right? That's it. Not too bad. Don't get scared. Not too bad. Okay, this is for today's main tasks. I think we will be able to done. We'll finish this web page probably within like 30 minutes, and we'll come back to here. So I'm letting you know what we have on the website. Okay. There's another one. I posted behind the labs link. It's on the 19th, which is Thursday's lab over here. So I generated another version of the in-lab and lab on my website. I couldn't imagine how students can do it if they don't have this one. Since I went through a lot of things, there are several bugs and have to fix. It should be a 2-week lab, but they put it in 1 week. Have you asked other students in the past how they passed this course?
Yeah, I have. They said just lots of hours staring at a light that won't turn on is what they said.
But could they finish?
They said it just took a lot of hours.
Okay, how many hours usually in general?
Like, I just asked how long were you taking? And she said it was just lots of late nights. So she would say that she would spend 2-3 nights just working on the code.
Okay, so it sounds like 20 hours.
Yeah, maybe 8 hours probably.
Yeah. So I don't have any homework assignments for the lectures for this week.
Yeah.
Because I know the workload is high. You haven't finished the lab 4 yet. Now we are having lab 5. And another thing could be possible. Okay. Since we don't have labs next week, right? I could probably make lab 5 a 2-week lab. How about that?
Maybe we don't have labs next week.
Right? Because next week is midterm, right? So there's no lab, no TA is going to check your results. So why not push it to the week after? Look at schedule. So we can do it on the 3rd of October. So in that case, in labs. Oh, we still have in labs. In labs is easy for lab 5. No worries. In labs, the code is provided. There are just several bugs. I think I already addressed it in my web page tutorials. Okay. The lab is hard. Oh, not really compared to lab 4. I think lab 4 is a bit challenging, for a 1-week lab. But lab 5 is okay.
What's the concept that we go over in lab 5? Is it all PWM?
Yeah, PWM. Timers, PWMs. Very similar concepts. That's a good deal?
Yeah.
Oh my goodness, I'm sorry guys. Looking at your face. Poker face, whatever you do, it's okay. Couldn't get anything done. That's all right. Do whatever you have to do. Okay? Is that the case?
No, I'm appreciative of this. Yeah, that's for sure.
I hope you guys can get the help you should get. I heard from Taylor, who is the department manager. It's the best way to manage TA office hours to have them do the office hour at the same time. So I think that makes sense. Just in case one of the TAs is not there, you can still have other TAs for sure, right?
Yeah.
So 3 TAs get scheduled during the 1 hour time. So this one, right? Okay, CCP1, PWM, control, control, right? Control bits. So I have to find out just open up the data sheet. Don't be lazy. Just open it up, double click, open up PDF, and search for CCP1 con. See? And here's a CCP1M. Usually if you see an M, it refers to a mode, right? It's CCP1 mode. CCP is a PWM mode, compare capture PWM, right? It's a register. And let's look at it. CCPXM, what is it? It's a mode. So like I said, there are 3 different modes for PWM, for peak, right? What are the 3 modes? Compare, capture, PWM, okay? So we are going to learn compare, not really capture. I'm wrong, but I haven't seen that yet. So mostly compare, and then the regular PWM. So for the lecture, for this web page, it's going to use compare. For the lab on Thursday, in-lab and lab on Thursday will be PWM. So I'm going to show you why we don't want to use compare all the time, because it's making the code really lengthy, and we'll see. So how to pick up compare mode for PWM output? Here, that's the register setting. 0010. Very simple, just set it up. Now let's see. 0010, compare mode.
Do we do like an MCC file and it configures a lot of those
Yeah,
things?
yeah. Not for this one, because this one doesn't have any MCC at all. You can try it in the lab if you want. So this one only has a main.c code. You directly copy and paste because everything here has already configured the clock and everything for MCC.
So you have to manually configure it every time?
Yeah, like this, right?
Gotcha.
Yeah, the frequency, the clock, and but not anything else. I don't think we have to use anything else. So for this one, if you want to repeat it in the lab, there's no MCC required. If you scroll it, go through it, you can see there's no FCC settings, right? This is what I did. I repeated. Okay, so the first setting is what? It could be on the exam. So what's the first setting? PWM what? Mode. What's the mode? Compare. Okay, compare. What about the second one?
Something select.
Yeah, it's a selecting timer 1 for CCP1 to compare. We'll see the code and see what's really going on over there, okay? So actually you turn on the timer, which is timer 1. How do you tell that the CCP or the PWM is using timer 1 to compare? So what's actually happening is you have a timer 1, you turn it on, timer 1 is going to count up, right? You have a register, it's going to counting from 0 to 2 to the 16th if you set it up for 16 bits. And whenever that timer reaches the value you put into register, which is this guy, CCP R1, when it equals each other, it's going to trigger the whatever mode it is. So this mode is toggle, right? So whenever it reaches reaches the same value you put into here, it's going to toggle the output. So what is the output? It's already tell you. It's a CCP1. We'll come back to here again. Don't worry about that. I'm going through this a little bit faster right now. So CCP1, if you look at the hardware here, that's a digital hardware for the PWM. All right. So let's see. You got this timer, which is timer 1. You already selected by that little line I just showed you, right? You selected timer 1 being used to compare with this little register for this CCP for this PWM module, right? They compare to each other. You see, from the top to bottom, they compare. Whenever they match to each other, you turn on this flag, which is CCP interrupt flag, okay? And then you toggle this pin. It's a physical pin on the chip. Okay, you toggle it. That's everything about this PWM mode. Now let's come back. It's here. So you're ready, set timer 1. Here's the selection bit, 0, 0, right? You can select the timer 1 is the one that you want to count. And what's happening here is timer 1, TMR1, has 2 bytes, right? It's timer 1 high, timer 1 low. Remember?
Yeah.
But no matter what, so timer TMR1 is going to be a 16-bit register holding that count. All right? So, and this one, whenever you turn it on over here, turn it on, give a 1 to it. So timer 1 will be on immediately. This is going to start counting, right? And this number, so whenever you call it, you put in here, it's going to give you a temporary count. And you add a certain number to that count, it's still counting. It's not stopping yet. It's still counting, right? But at this moment, whenever the programmer pointer, right, if you put into, you download everything to you compile it, put into the chip, the code, the C code will be compiled into machine code and stored in the program memory, right? So there's a memory pointer taking every single instruction from the instruction memories one by one, from top to bottom. So whenever it's on, right, it's getting to the for loop immediately. It's gonna do the first one first, right? What's happening is the timer 1 count at the moment will be added to this certain count, and then assign it to this register. This register is for the PWM. So the timer 1 count at that moment will be recorded. Okay? But is timer 1 stopping? No, it's still counting. You didn't stop it. Did you stop it? No, you didn't. You don't have any code to stop it. It's not stopping. It's still counting, right? So what's happening is, because you have that earlier timer 1 count added a big number, so you are setting a number ahead of time. Does that make sense?
Yeah.
So at the moment here, right, you are setting a big number here, but timer 1 was here. So timer 1 will keep counting until it reaches here and it matches.
And when it matches, it gives a flag?
Yeah, matches, it's gonna toggle.
Gotcha.
That's how you set it. Does that make sense for this code? So it's gonna toggle which, if you look at the hotwire here, so there are two actions. When it matches, there are 2 actions. What are the 2 actions? Here. What's that?
It either sets or resets the bit right there, the output.
Toggle this, right? Since that's what we set for the mode. It's gonna toggle this one first, second, flag. That's the 2 actions. Flag is on, toggle it.
Yeah.
Toggle what? Toggle this physical pin. It's the physical pin. Where is it? Five-star service is over here, showing you everything. I hope my teacher in undergrad did the same thing. Anyway, so let's take a look at it. Where is CCP1? CCP1, see? RC2. So if you probe RC2, what you are going to see? It's getting toggled. What's the frequency? How to calculate the frequency?
The half period is the 8112.
Yeah, this guy, right? How to convert this to time?
Multiply by 2 and then divide by it.
If we don't have any prescaler, nothing. 16 megahertz.
Yep, 60.
How long it takes for 8,112 counts.
8% over 60 megs.
So this number do what?
Divide by 60.
Divided by 60 mega, right?
Yeah.
So get the time. That's how long for the period or
Half period.
half period, because that toggles every half period. It's not an entire period, it's half, 50% of the period. Make sense? So you can control how long you want to, what's the frequency you want to toggle that pin. However, it's still not PWM. Is it PWM? No, it's 50% duty cycle. Okay? So now let's see. I think it's in the second example here. That's the main code for PWM. How do you implement PWM with this not toggle now? So we are not talking about toggle anymore. Okay. So what's happening here is you can change the mode. If you look at the mode settings, so here's a toggle, right? Toggle. toggle. And also you can see there are another 2 different modes. It's also compare mode, right? But however, for 100, if you put a 1000 into that register, and you're setting the result, you're setting the output with matches. And if you put this number into the register, you are clearing the output with matches. It's still at compare mode. However, you can control it. It's clearing, it's putting it 0 or giving a 1 to the output instead of toggling. So why that helps? So if you look at the code, you will probably laugh. It's not really, it's a bit awkward, but it's okay. It works. Now let's see. So now, assuming we are at the, we are not at the toggling mode anymore, okay? It's not toggling. So when it matches, it's not toggling anymore, okay? It's either setting, you put a 1, or put a 0 to CCP1. What is CCP1, just in case? Which pin? RC what? RC2, right? Where to find it? Here, right? However, I have to let you know, there's something wrong with it. So see RC1, CCP2, no, RC2, right? CCP1. It's multiplexed. Anyway, so if you look at here, CCP2. CCP2 is the second PWM module we're going to use for the lab. Don't worry about that for now. But if you look at CCP2, it's RC1, right? It's RC1. However, you'll see, hey, there's another CCP2. It's RB3. So which one should we use? I haven't figured out that yet, okay? I have to look into the data sheet and find out later. I'll let you guys know. But for the lab, I think we're good. We just use these 2 pins, and if we just take PWM module 2 out and use it, it's going to output to RC1. I haven't tried to set up this pin yet, but we don't have to worry about that for now, okay? But just let you know, so you are not getting confused. Let's use CCP2 here, CCP1 here, and RB5 here for CCP3. So that's the 3 CCP PWM modules we're going to use for the lab. RB5. Okay, keep in mind it's recorded, so you can always come back to find out. And now let's come back to the code. All right. Come back to the code here. Remember, you can give a different 4 bits or nibbles to the control register to set up. You want to set the pin, which is RC2, right? You want to set RC2 or clear RC2 whenever it matches. Okay, so timer 1 is on, matches, set or reset. So now, if it's setting. Okay, so for example, this 1000, it's setting. If you set it as setting the pin RC2 whenever it matches, immediately you make it to be clearing. So you know what I mean? So whenever it's how that works, because you are actually changing the mode every time. So if you change the mode every time, you can change the pulse width instead of just to keep toggling the pin with a 50%. Why that works? Let's see. So if now it's setting, okay? So when it matches the setting, I immediately make it to be clearing.
Yeah.
So now during this cycle, it's gonna clear it whenever it matches, all right? So I put a duty here. That's the duty I want to use. I put a hat of timer 1 to this register, right? So it's gonna keep chasing this guy, and whenever it matches, what's gonna happen? It's gonna clear it.
Takes the right time.
It's gonna clear it. So what's happening? Let's see. So is that duty a really duty over there? Yes. Why? Because it's clearing. So what's happening is this, right?
Yeah.
It's clearing. So that's the duty. All right? Okay. So the second time it gets into the loop. If this one is satisfied, is it still going to do this? No, it's gonna, because they are at the same level, right? So once this one is being checked, it's gonna go through this code and skip this one, right? And then move to the next.
So the while thing is just waiting until that interrupt flag is equal to 0.
Oh yeah, because it's trying to make the duration here to make the duty happen, right?
So So it'll be there, and then after that's done, it's out of that while loop.
Yes.
until the if.
Yeah. So when the flag is on, which means it matches, right? Mm-hmm. Right, when it matches. Oh wait, no.
That's just waiting until the flag pops up again, right? Because you clear the flag and then
Yeah, when the flag pops again, yes.
you get out of that.
Yeah, you get out. And then comes to here. These are just something else. You are changing the duty, right? So let's skip this one for now because this is just changing, making a new duty value for the next time it gets into this forever loop. So now when it comes back, because the next time the mode setting becomes this guy, right? So I'm gonna skip the first one and get into the second one. And it's using the period minus duty this time. So it's actually the desired duration for the off time. Okay? Because it gets into this one immediately set as set whenever it matches. So what's happening is we need to make a desired duration here, and because the next time you get into this condition, it already changed to set. So that's why whenever it matches, it's gonna set it. Okay?
So period minus duty, what does that mean?
That's off time, because that's a period. That's a duty, right? That's the off time. So the second time it gets into it, it's gonna use this one for timer 1. And after timer 1 overflows, it's gonna set it. Why? Because it's using this mode right now.
Gotcha. So this is also.
Yeah, so it's changing the mode every time. So you can change the on and off time every time.
Gotcha.
So it's not 50% all the time because the first time it's doing the duty, the second time it's doing the period minus duty. All right.
So you can modify the on and off time.
Okay. You can always come back and revisit this. It's okay. It's all right. But that's the main concept of using the clearing and setting these two modes to implement PWM. And these two are at the same level of the first if statements. So that's another button controlling. If you press it, it's going to add a certain number to that duty or minus a certain number to that duty. So you can change the duty cycle. So what's really happening is if you download this code to your microcontroller and you can keep pressing RA2 as a button connect to RA2 to change the pulse width. RA2 and RA3. If you press RA2, it's going to make it wider. Okay, you can look at the oscilloscope. It's making it wider, pushing wider, right? If you push RA3, it's going to make it narrower. Okay, you can change you can look at the change in real time. If you connect it if you connect RC2 to a LED, you'll see it's getting brighter and dimmer, right? You can try it, but I don't think this is a homework assignment. It should be a homework assignment, but I didn't assign it because I know the workload is high this week. So, but now let's go through these calculations. All right. Can I read it on the back? From the back, can I read it? You can also open it up from your phone or laptop if you want. So first one, assume the timer starts counting at this, all zeros, right? What value of CCP1 will set this flag in 1 millisecond? 1-to-1 prescaler.
Timer 1 plus however many counts you need to get 1 millisecond. So
Yeah, but yeah, what's the count? So eventually, so this will start counting, right? This is a number in the timer at the very beginning. So whenever, after 1 millisecond, what the counts will be in timer 1. How to calculate it? 1 millisecond do what? Wait, no. Times, right? Because the 60 mega per second.
Oh, yeah.
1 times 10 to the mega to 3rd times 16 mega.
So it's 1 divided by 1,000, converted to second first, right? And then times 16 mega.
Mhm.
What's the second one?
16,000 counts.
Similar, right?
Yeah.
It's just a different time duration. Are you all getting this? This is not a new thing, all right? Still the same thing we have been doing for the past 2 weeks. Timer stuff. Right? It's pretty cool, right? A lot of you don't like it. Let's do something new.
Sorry, where is this on things?
What's that?
Where is this on the website?
Oh, it's
Sorry.
no problem. Here.
Oh, okay.
Yeah. This is today's date, right?
Yep.
It's here. Scroll it down to the bottom.
You can do anything.
Number 3. Counting from 0, count to this. How long it takes? How long it takes? So a count is given. How long it takes?
2,000 counts divided by 16 megabytes.
Is that 2,000?
Oh, my bad.
Right? Convert this one to a decimal number, right? So counts is given. Asking for time, right? Always think about the units. This will be definitely on the midterm. We haven't learned too much yet, so probably there will be like 100 problems for timers on the midterm. I'm just kidding. We don't have anything else, right? What else do we have? 50 minutes. Think about 50 minutes. How many?
What is this for?
Binary conversion.
Yeah, so 15 minutes times 16 mega. So how many problems we should put on the midterm exam?
That sounds
Oh, you don't have a pick in your brain. Okay, let's make so OX Elon Musk will make it happen, right? Neural interface. Get an electrode connect to the neurons. So that's what? That's counts, right? How long it takes to finish?
Divided by the frequency.
Yeah, 16 mega per second, right? If you want to get second out, you have to divide this one so you can flip second to the top. So second, you can flip to the top. If you still couldn't do it, take 5 hours to do it. Take 100 problems and practice so you can pass the midterm.
This is just the entire midterm right here.
Yeah? You hate it? What else I can do?
I'm not upset about it.
Yeah? I'm sorry. I cannot get rid of everything, right? Let's waive the midterm. Let's waive the labs. Let's take the Christmas break from now. I like it. I will do it.
Just keep the grades as they are.
Yeah. Yeah, you register for this class, have to do it, right? Okay. Counts. So I'm telling you how to be successful over here, okay?
32 seconds.
It's not too difficult. Counts. Flip it to the top. If you still couldn't do it, I was exaggerating, but maybe 20 examples from the website, from the homework assignments. Just sit there, do it. If you still couldn't do it, find a TA, find myself, watch the TV, watch the videos, recorded videos. Make sure you can get 100% right, okay? There will be just a lot of problems on the midterm. What's that?
So are you thinking like test your knowledge section on all of Colson's stuff will be pretty close to what the midterm will be like?
Golson stuff?
Like, because you took that off of Colson's website, the test your
Oh,
knowledge
Colson
bit.
website. Yeah, similar, right? So everything, whatever has been covered in the in-labs, so the questions of the in-labs, the questions from the homework assignments, that's it. I'm not taking anything beyond that.
In labs, there's always like questions that ask like, oh, what does this pin do? What does this pin do?
Mhm.
If you're asking those questions, will we have like access to the data sheets as well?
I'll probably have a snapshot at the at
Gotcha.
the end of the
And then
exam.
we just read the data sheet from the snapshot. you
Yeah,
gave us? Okay.
yeah. Instead of directly telling you what the registers are, I'll let you look through it from the appendix or something.
Gotcha. Thank you.
All right. Good question, though. Okay. To make you guys more comfortable, we just spent a lot of time to talk about other things this class. Haven't covered too much yet. But we still have Wednesday I think we'll talk about lab 5 on Wednesday and in labs. Make sure you guys can be successful for that lab. It's going to be a 2-week lab. I'll let the TAs know, all right? Okay, problem number 4. Let's just relax. We only have like 7 minutes left. Let's just finish the last 2 problems. Now I'll let you go. All right? Relax. No worries.
So do that minus that.
Could you do number 4?
Yeah.
Let's pause a little bit. Give everyone the time to think through this problem. What is this? That's a flag.
Yeah.
Whenever it matches, this becomes 1. That's a flag we just learned. Okay? So you have a start counting of this, which is apparently larger than this guy. What's going to happen? It has to overflow first and then start from 0 and then reach this number, okay? How long it takes? How many counts in total? How to calculate it? Mm-hmm.
I just take the remainder that
Yeah.
you have to get till you overflow there, and then
Yeah.
add on the
1,000 count.
Yeah.
1,000.
Yeah,
whatever
cool.
it is
Yeah,
next.
yeah, cool. Anyone else can tell me as well?
Is there an easier way to do it?
No, I mean just the same thing.
Yeah,
They
so
didn't hear it.
5%.
So you use this one is the starting value, right? You have 2 to the 16th.
Which is the way he was saying it.
The only thing is that, like, are we gonna have to we would have to convert that line, you know?
It's gonna overflow. When it overflows, you just
Flag turns on.
So look at the number here. This number. Pay attention. This is one of the problems in the midterm. Okay. This number is starting value, right? You have to get the remaining done first, which is 2 to the 16th minus whatever here, right? Right? Okay, get that done first. And then start counting from 0 until this number. So that's the total number of counts. Okay? How long it takes? Divided by 16 mega. Okay? That's the time delay. It's asking for time delay. What delay is generated? Because holding here all the time is a while loop. Whenever they match, it's gonna turn on the flag and get out from the while loop, right? That's why it's the time delay is generated. What about the last one? I'll let you go 2 minutes earlier.
Sorry, could you move it over so I can see the paper again? I just
Oh, sure. Oh, because it's gonna be on the midterm, that's why. Getting more serious. Everybody is getting more serious. Where's my pen? Take a picture. Good? All right, last one. How long does it take? How long?
2,000 over.
so timer 0 has a 1-to-1.
Yeah, 1-to-1. Yeah, it's telling you here, 1-to-1. So what this does is just setting the timer ahead, right? Not setting timer, setting this register, whatever value being put in that register ahead of timer 0, right? But timer at the moment of timer 0, so timer 0 will not stop counting, so it's gonna keeps counting until it matches whatever being put in here. So it's gonna be this count, right?
Yeah.
So that count, how long it takes? No, how long does it take? Is that number divided by 60 mega, right?
Just the number you're adding to.
Yeah. That's how long it takes, right? Any other questions? Still have 2 minutes, I'll let you go. So find a department to get like whatever refunds, okay? For the 2 minutes. See you on Wednesday.